Good evening. Welcome you all for today's session. The session is on basic theorems and properties of Boolean algebra. So first, the laws and rules of Boolean algebra consists of two concepts. One is Boolean addition and another one is Boolean multiplication. Boolean addition is similar to OR function and Boolean multiplication is similar to AND operation. So this Boolean algebra was invented by George Boole in 1854. It is a mathematical system for the manipulation of handling one or two values. It helps to reduce the number of logic gates needed to perform a particular logic operation and resulting in a list of functions or theorems known as the laws of Boolean algebra. So here you can see the operators. One is OR function and another one is AND function, that is addition and multiplication function. The AND operator can be described using the truth table, and the OR operator is also known as a Boolean product, which is explained in this truth table. So first, AND function, if both the inputs are low, your output is low. If both the inputs are high, not only if both the inputs are low, even if one input is low, your output will be high. Output will be 0. And if both the inputs are high, the output will be high. This is AND function. And OR function here is vice versa of AND function, that is even if any of your input is 1, that is high, then the output will be high. So this is the function of addition and multiplication of Boolean function. Here we have certain rules to follow this, like binary values high for 0 and low for 0 and high for 1. Logical ANDing of the two or more variables is represented by writing a dot between them, such as A dot B dot C. Sometimes the dot may be omitted, like A, B, C. So there are 5 types of Boolean laws: commutative law, associative law, distributive law, etc. So in the first law, commutative law, this can be explained as which satisfies the following expression, which is given here, like A dot B is also same as B dot A, and A plus B is also same as B plus A. So the left hand side is equal to right hand side. This law states that changing the sequence of the variables there is no any effect on the output of a logic circuit. And next one is associative law. This law states that the order in which the logic operations are performed is irrelevant as their effect is the same. A dot B dot C is equal to A dot B dot C. A plus B plus C is equal to A plus B plus C. So you can see the difference here, right? Next one is distributive law. This states the following conditions, like A into B plus C can be distributed as A dot B plus A dot C. You can see the AND operation, so called as AND laws. Next, the remaining laws are AND operations and OR operations, like AND is multiple functions, like A into 0 is equal to 0, A into A is equal to A into 1 is equal to A into A bar is equal to 0. And the OR operation is OR laws, represented as OR laws, like A plus 0 is equal to A, then A plus 1 is equal to 1, A plus A is equal to A, and A plus A bar is equal to 1. These are the laws. Fifth law consists of AND and OR laws. And next one is inversion law. By the name inversion itself, we can understood that it is a NOT function, like it uses NOT operation. The inversion law states that double inversion of a variable results in the original form itself. If A is double time components, then it is equivalent to A. Okay, so this is all about inversion law. And the laws of Boolean algebra that relate to the commutative law: change in position for addition and multiplication. These Boolean laws detailed can be used to prove any given Boolean expressions, as well as for simplifying complicated digital circuits. So here we can see some example, the left hand side and right hand side, you can see some derivations like binary variables which represents the constants as 0 and 1, and the logic symbols. So Boolean function is equal to Boolean expression. F of a, b, c, d, f represents the function of Boolean concepts, and the right hand side it represents the expression of Boolean expression, that is Boolean expression. So the left side of the equation represents the output y, where y is equal to a plus b c bar plus a d c. So this is the example here represented. And another theorem here is duality theorem and principle of duality. There are two De Morgan's rules here. De Morgan's theorem, there are two here. One is a dot b whole bar is equal to a bar plus b bar. This is the first rule. And next one is b bar, a plus b is equal to a into b whole bar. Okay, thank you.